In chapter 6 we will look at bivariate distributions. By bivariate distributions we mean we'll be looking at two variables. Okay, two variables. And usually x and y. We'll be talking about probabilities that x can take, y can take, x and y can take together, and then we'll talk about correlation, and we'll do a little bit on hypothesis testing. Okay, let's start slowly with discrete bivariate distributions. So we'll be looking at tables giving us x values, y values, and the associated probabilities. Okay, and we'll be expected to work out some expectations, whether it's expected value of x, expected value of y, or expected value of xy. So let's go through an example. In example 1, we are asked to find the value of k that you see in the table. You're asked to work out the expected value of x, expected value of y, and the expected value of xy given the data in this table. So let's talk about the table first. Okay, you'll see a k in the table here. Now, a few things about this table. Take note, all these values here that you see, 0.3, k, 0.1, 0.2, 0.05, and 0.15, these are all probabilities and they must add up to 1. Okay, all the probabilities in these cells must add up to 1. That's the first thing. So let's make a note here. So sum of probabilities in table must be equals to 1 because we're dealing with a probability distribution, except that it's of two variables. That's the first thing. The second thing is the number that you see as 0.3 is the probability of x equals to 0 and y equals to 1. Again, this probability that you see here, 0.3, is the probability of x equals to 0 and x equals to 1. Excuse me. Probability of x equals to 0 and y equals to 1. So that value here is 0.3. So this value of 0.2 will be probability of x equals to 2 and y equals to 2. Good. In statistics we call them joint probabilities. Yeah, probability of x equals to 0 and y equals to 1 is 0.3, and probability of x equals to 2 and y equals to 2 will be 0.2, and so on. Then this column here, okay, when you add it up you'll get a probability of x equals to 0. This column here, when you add it up you will get probability of x equals to 2. This row here, when you add it up you will get probability of y equals to 1, and this one, when you add it up you will get probability of y equals to 2, and this last row, when you add it up you will get, let me write it this side, you will get probability of y equals to 3. Okay, again, the first column, when you add it up you will get probability x equals to 0. The second column, when you add it up you will get probability of x equals to 2, and the rows probability y equals to 1 is the first row when you add it up. The second row, when you add it up, 0.1 and 0.2, you'll get probability of y equals to 2, and the third row, when you add it up, 0.05 plus 0.15, you'll get probability of y equals to 3. Okay, so now we can work out k, the expected value of x, expected value of y, and expected value of xy in this question. So the sum of the probabilities equals to 1, so that's what I've done here. 0.3 plus k plus 0.1 plus 0.2 plus 0.05 plus 0.15 equals to 1. So the sum of the probabilities equals to 1. Using a calculator, you will get k equals to 0.2. That's easy. The expected value of x, we will use the formula summation x px. So I've written the possible values of x here, 0 and 2, and the probability of x equals to 0 is 0.3 plus 0.1, which is 0.4, plus 0.05 will be 0.45. That's what you see here. Okay, that's the probability of x equals to 0. Just add the numbers up in this column. Do the same thing for probability of x equals to 2. Add the numbers up in this column. K is 0.2. 0.2 plus 0.2, 0.4, 0.4 plus 0.15 will be 0.55. Alternatively, you could have taken 1 minus 0.45 and obtained 0.55 because there are only two possible values for x. So the expectation of x, that's easy. Just take 0 times 0.45 plus 2 times 0.55. Use a calculator and you will get 1.1. Good. Do the same for y. Okay, probability of y equals to 1 will be 0.3 plus 0.2, 0.5. Probability of y equals to 2 will be 0.1 plus 0.2, 0.3. And finally, probability of y equals to 3 will just be 0.2. So the calculation for the expected value of y is just y times the probability of y. So 1 times 0.5 plus 2 times 0.3 plus 3 times 0.2. Use a calculator and you'll get 1.7. The expected value of xy, let's write a formula here. The expected value of xy will be summation xy times the probability of x and y. Again, the expected value of xy will be xy, which is a product, times the probability of x taking the particular value and y taking the particular value. Good. So let's look at some of the entries when you want to work out the expected value of xy. I've done it here. Okay. Just take x equals to 0 and y equals to 1. So 0 times 1 is 0 and 0 times 0.3 is 0. That's what you see here. And if you take, let's say, x equals to 2 and y equals to 2. So if you take x equals to 2 and y equals to 2, that's what you see here. 2 times 2 will be 4 and 4 times 0.2. Okay, you need to do these calculations for all the cells. It's quite easy in this case because of the fact that x is 0 here for all these three cells, so life is pretty easy. So you just have to worry about these cells. Okay, x is 2, y is 1. Okay, and then we have a k here, and then x is 2, y is 2, we have a 0.2. X is 2, y is 3, we have a 0.15. Okay, use a calculator, work all the numbers out, and you'll get 2.1. Example 2. For the following distribution, you're asked to find the probability that A equals 1 given that probability B equals to 2. So let's remind ourselves of some formulas. Probability of x given y, the conditional probability will be probability of x and y over the probability of y. So we're going to use this idea. Probability that A equals to 1 given that B equals to 2 will be probability of A equals to 1 and B equals to 2, the whole thing divided by probability of B equals to 2. We learned this when we talked about conditional probability in our earlier course. So first things first, they have a k in the table we can easily find. Just take 1 minus 0.35 minus 0.15 minus 0.25, because we know the sum of the probabilities in the cells must be equals to 1. When you do that, you will get k equals to 0.25. And I've written the formula here again. Probability of A equals to 1 given that B equals to 2. This is how you deal with it. Okay, probability of A equals to 1 and B equals to 2 over probability of B equals to 2. Now, probability of A equals to 1 and B equals to 2, that's here. Okay, that's found in this cell here. A equals to 1 and B equals to 2, 0.35. Probability of B equals to 2, you have to go along the row here. Okay, probability of B equals to 2 will be, let's write it here, will be 0.35 plus K. Let me include the 2. Good. So probability of B equals to 2, just add the probabilities in this row. 0.35 plus K we worked out to be 0.25, which will be 0.6. Okay, so you will have 0.35 divided by 0.6. Use a calculator and you will get 7/12. Next example. For the following distribution, we are asked to find the expected value of A given that B equals to 2. So the formula we are going to use, expected value of X, will be summation X Bx. This is the idea. Okay, the expected value of X will be the X value times the probability that X will take that value. So in this case, except that it's a conditional expectation, so the expected value of A given that B equals to 2, we can write it as the sum of the probability of A multiplied by the probability of A given that B equals to 2. Again, the expected value of A given that B equals to 2, we can write it as the sum of A times the probability of A given that B equals to 2. But the probability of A given that B equals to 2 will be equals to the probability of A and B equals to 2 over the probability of B equals to 2. Probability of B equals to 2, that's easy. Just go along the row and add the numbers up. 0.1 plus 0.5, you will get 0.6. Now this one here, probability of A and B equals to 2, we have to consider the case when A equals to 1 and the case when A equals to 2. So that's what I've done here for you. Okay, so this value A, let's just say first the value of A we take is 1. Okay, take A equals to 1, and then A equals to 1 and B equals to 2, the probability is 0.1. That's what you see here. Again, first consider A equals to 1, so you take 1 times probability of A equals to 1 and B equals to 2 will be this number here. That's what you see here, and then you divide by probability of B equals to 2, which is 0.6. Repeat that for A equals to 2. So this is a sum, so plus 2 times, now this is the value of A, 2 times probability of A equals to 2 and B equals to 2, so that will be this number here, which is 0.5, and divide by probability of B equals to 2, which is 0.6. Add both these terms up, you'll get 11/6. Next example. The discrete random variable X can take values 0 or 2, and the discrete random variable Y can take the values 1 or 3. Their distribution is defined by probability of X equals to X and Y equals to Y is given as K times X plus Y. We are asked to find the variance of X and the expected value of XY. First, let's set up a table. Okay, X can take values 0 or 2, Y can take values 1 or 3. So when X is 0 and Y equals to 1, so the probability, okay, X equal to 0 and Y equals to 1 will be just K 0 plus 1. Again, we know it's k times x plus y, so x plus y here, 0 plus 1 is 1, 1 times k will be just k. That's what you see here. Let's do one more. Probability of x equals to 2 and y equals to 1 will be k 2 plus 1, so you'll get 3k. That's what you see here. So repeat for the two other cells. You'll get 3k here, and you'll get 2 plus 3 is 5, so you'll have 5k here. Good. Set this table up, and you know that when you sum the probabilities in all the cells here, you must get 1. So k plus 3k plus 3k plus 5k, you must get 1, so you'll get the value of k as 1 over 12. Good. We are trying to find the variance of x, so we need the probabilities. So let's work it slowly. Probability of x equals to 0. Add the probabilities in this column, k plus 3k, you will get 4k. Again, probability that x equals to 0, just add the probabilities in this column. So k plus 3k is 4k, k you know is 1 over 12, so 4 times 1 over 12 is 1 over 3. So let's write x and px. Okay, so 0 will be 1 over 3, and then I have x equals to 2 will be 3k plus 5k will be 8k, and 8k, 8 times 1 over 12 will be 8 over 12, which will be 2 over 3. So now you know the x values and the probabilities. You can work out the expected value of x, and you can work out the expected value of x squared, and we'll be done. So follow the working here. The expected value of x is summation x px. So 0 times 1 over 3 plus 2 times 2 over 3, you will get 4 over 3. The expected value of x squared, 0 squared times 1 over 3 plus 2 squared times 2 over 3, you will get 8 over 3. So to find the variance, just take expected value of x squared minus expected value of x whole thing squared. 8 over 3 minus 16 over 9, you will get your final answer 8 over 9. Good. The expected value of xy, so we don't have to worry about this cell and this cell, we just have to worry about this cell here and this cell here, simply because when you take xy, the product of x and y, because here x is 0, so it's not going to affect our answer in any way. So first you consider x equals to 2 and y equals to 1. That's what you see here. And the probability of x equals to 2 and y equals to 1 will just be 3k. Good. And then we go to the next cell, x equals to 2 and y equals to 3. And the probability is 5k. So I have got 6k plus 6 times 5 is 30, 30 plus 6 is 36k. What is k? 1 over 3. So 36 times 1 over 3. Okay, and excuse me, k is not 1 over 3. K is, let me write it here, is 1 over 12. Okay, k is 1 over 12. So 36k, 36 times 1 over 12 is 3. Next example. The random variables x and y can only take the values 0 and 1. The expected value of x is 0.4, the expected value of y is 0.3, and the expected value of xy is 0.1. We are asked to find the probability x equals to 0 and y equals to 0. So I've set up this table here. It's quite easy to follow. X can take 0 or 1, and y can take 0 or 1. So I've included some probabilities in the form of A, B, C, and D. Okay, let's first take care of expected value of xy. Before that, remember we are trying to find probability x equals to 0 and y equals to 0. That means we are trying to find A. Okay, now expected value of xy equals to 0.1. The good thing is here x is 0 and here y is 0. So when you take the products, when you take the product, most of the terms here is 0 except for x equals to 1 and y equals to 1. Okay, this one here, x equals to 1 and y goes to 1, we have a probability of d. So I have 1 times d equals to 0.1. So d equals 0.1. Again, all the others, they disappear because of the fact that x is 0 and y equal to 0. Okay, good. Expected value of x they gave us is 0.4. so remember x, let me write it here, probability of x can take values 0 and 1. Now I don't want to bother about x equals to 0 because when I take 0 and multiply by a probability, I'm going to get 0 anyway. So let me just focus on x equals to 1. Probability of x equals to 1 will be just b plus d. So let me write it here. Probability x equals to 1 will be b plus d. So the probability multiplied by the value of x equals to 1 will give me 0.4. So b plus d times 1 equals to 0.4. So d I know is 0.1, so I'll get my b as 0.3. The same logic for the expected value of y. So y, we'll have probability of y value is 0 and 1. I don't want to worry about y equal to 0, I just worry about y equals to 1. It is just c plus d. Okay, here probability of x equals to 1 will be b plus d. So I take c plus d times 1 must give me what? 0.3. So c plus d times 1 is 0.3. We know d is 0.1. You will get c equals to 0.2. So you know d 0.1, you know b 0.3, you know c 0.2, you know the sum of probabilities is equals to 1. You take 1 minus b minus c minus d, you will get a, which is 0.4. Okay, most of this page contains important ideas and formulas that we are going to use when we study bivariate distributions. The first fact is the covariance. Okay, the covariance. The covariance of xy is given by this formula. It's the expectation of x minus mu x times y minus mu y. Again, covariance xy, okay, the covariance of xy is defined as the expected value of x minus mu x times y minus mu y, where mu x here is the expected value of x and mu y here is the expected value of y. Okay, that's the definition of the covariance of xy. Now when you clean this up, you can do some algebra here and you get a simpler version. The covariance of xy will be the expected value of xy minus mu x times mu y. You can open this up, okay, expand and arrive at this expression. If you have n data points, then you can get the covariance of a set of data, okay, by taking summation x minus x bar times summation of x minus x bar times y minus y bar and dividing the whole thing by n. Again, if you have a set of n data points, you can get the covariance, okay, by using this formula, summation of x minus x bar times y minus y bar divided by n. Okay, the covariance tells you how two variables move. Okay, if they move together, then your covariance is positive. Okay, if they move in opposite directions, then your covariance is, let me write it here, then your covariance is negative. Okay, when I say move together, that means when x goes up, y goes up. That's what we mean by moving together. Or when x goes down, y goes down. And when we say they move in opposite directions, when x goes up, y goes down, or when x goes down, y goes up. So if they move together, the covariance is positive. If they move in opposite directions, then the covariance is negative. Okay, that's conceptually what covariance is. We also have another measure here, which is called the correlation coefficient. The correlation coefficient is given as the covariance of xy divided by sigma x times sigma y. What is sigma x? It is the standard deviation of x, the square root of variance x. Sigma y will be the standard deviation of y, the square root of the variance of y. Okay, the correlation coefficient is something similar to the covariance, except that it is the scaled version of the covariance. Okay, it's a scaled version. Okay, take note, covariance, we have a formula, expected value of xy minus mu x times mu y. The correlation coefficient, this is called rho. Yeah. Okay, the correlation coefficient is covariance xy divided by sigma x times sigma y. Now, rho here will take values between -1 and 1. Okay, no units. Okay, no units. It's just a number between -1 and 1. Good. Now, if your variables x and y, if they are independent, then rho is 0 again. If your variables are independent, okay, if x and y, the variables are independent, then rho equals to 0. The correlation coefficient is 0. And if your variables are related in this form, y equals to mx plus c, straight line, yeah. Again, if your variables x and y have a linear relationship, y equals to mx plus c, then rho will be either plus or minus 1, depending on which way the line is sloped. Okay, then you have a plus 1, and if it's like this, then it's a -1. Again, if your x and y, they have a linear relationship, y equals to mx plus c, then your rho is either plus or minus 1. An estimate for rho is given by r. Okay, an estimate for rho is given by r, and it's called the sample product moment correlation coefficient. Okay, sometimes I just call it sample correlation coefficient. Again, estimate for rho is given by r, and r is the sample product moment correlation coefficient. I usually call it the sample correlation coefficient. Okay. Okay, now there's this formula in your formula sheet on how you work out r. Okay, your sample correlation coefficient r, we can work it using this formula. Okay, summation xy minus n times x bar y bar, the whole thing divided by this thing here that you see in the denominator. Okay, so if you are going to do a degree in statistics or engineering, it may be useful for you to know this formula. But anyway, it's available in your formula sheet. Okay, how you work out your sample correlation coefficient. A few things about r. So remember, we are talking about two variables, x and y. So if all the points, if you have a set of n data points, you have measured x and y, and let's say all the points lie on the line, on this line, then r will be plus 1. If you have, let's say, another line here, and all the points lie on the line, here r will be -1. So I'm trying to tell you something about what is the meaning when you get r equals plus or minus 1. So if r equals to plus or minus 1, then we have what we call perfect positive or perfect negative linear relationship. So this one here, let me write it here, this one here will be perfect positive, and this one here will be perfect negative. So perfect positive linear relationship, and here perfect negative linear relationship. Okay, you need to know this. If r equals to 0, what does it mean? If r equals to 0, it means no linear correlation. Okay, so don't forget this word, linear. If r equals to 0, it means no linear correlation. There may be some other relationship between these two variables. Okay, all we are saying is there is no linear relationship between these two variables, x and y. Good. One more fact here on hypothesis testing. Let's go through it line by line. We are testing h0 rho equals to 0 against h1. Okay, the alternative hypothesis, rho not equals to 0. Okay, we are testing the correlation coefficient rho equals to 0 against the alternative hypothesis, rho not equals to 0. Now the way we carry out the hypothesis test, we know we are going to work out p-values and compare it with our alphas and so on. So the important thing that you need to catch on to real quickly is this fact here. Okay, t is r times the square root of n minus 2 over 1 minus r squared. Again, we have r times the square root of, again, r times the square root of n minus 2 divided by 1 minus r squared. You need to know this. Okay, it's given in your formula sheet, and this test statistic, so let's write it here, this test statistic is what we're going to use, and it'll be a t distribution. Okay, we're going to work out the test statistic. Okay, we'll work out r, we'll know n, and we can get this test statistic out, and it has a t distribution with n minus 2 degrees of freedom. Okay, n minus 2 degrees of freedom. Now we're going to carry out this test, work out the p-value, and look at alpha and draw our conclusions. So basically we are trying to test whether there is any correlation or not. Okay, good.